Today's lesson is section 5.2, quadratic equations in standard form. We're going to go from standard form to vertex form, but I'm going to first show you a method to sketch a quadratic equation. I'm going to give you these steps. It says, what is a graph of y equals x squared plus 2x plus 3? You first have to identify your A, your B, and your C. And this is the formula to find the axis of symmetry. X is equal to negative b over 2a. And you notice that your axis of symmetry for this situation is x equal negative 1. Since we know that the vertex is on the axis of symmetry, that's actually your x-coordinate. So your x-coordinate of the vertex is negative 1. You substitute into the original equation, and once you substitute into the original equation, you get 2. And then you plot the vertex negative 1, 2, which is right here. So here is the axis of symmetry that we found from the formula, x equals negative 1. We did a substitution, and we found the vertex was negative 1, 2. And we know that it's going to open up. We also know that if we let x equal 0, then we know that the y-intercept is going to be 0, 3. 0, 3. And this is like your mirror. So to find the other point is right here. So you have 3 points. You're able to sketch the graph with just 3 points. So now you know that the domain is all reals. You know that the range is y is greater than or equal to 2. And you also know that the vertex is negative 1, 2. And it's a minimum point, right? So we're going to graph this equation the same method. We're going to identify the coefficients. So we have A equals 1, B equals 6, C equals 9. I know that the axis of symmetry, the formula, is negative b over 2a. So b is negative 6 over 2 times 1, which is negative 6 over 2, which gives us negative 3. So since I know that the axis of symmetry is negative 3, it's going to be 1, 2, 3. I know that the x value of the vertex is negative 3, so to find the y value, it's negative 3 squared plus 6 times negative 3 plus 9. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 9. 9 plus negative 18 is negative 9. Negative 9 plus 9 is 0. So what's the vertex? The vertex is negative 3, 0. The vertex is negative 3, 0. Now, if I want to find the y-intercept, I know x is 0, so it's going to be, if I substitute into the equation, it's going to be 0 squared plus 6 times 0 plus 9. So the y-intercept is 0, 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is your mirror. X equals negative 3. So it's 1, 2, 3, 1, 2, 3. And then I just sketch it. And there's my graph. Now I didn't do a good job of it. Let me fix it. There's my graph. On the left side, I went ahead and showed you the answer. So there is the answer. Okay, we're going to go ahead and we're going to graph using the formula, axis symmetry formula. So you need to identify your coefficients, which in this case is A, B, which is 10, and then C, which is 7. So we know that the axis of symmetry is going to go right through the vertex. So we have x equals negative 10 divided by 2 times 1, which gives us negative 5. So it's 1, 2, 3, 4, 5. So I'm drawing the axis of symmetry. Now, since I know that the vertex is going to be on the axis of symmetry, I'm going to substitute into my equation y equals -5 squared plus 10 times -5 plus 7, which is 25 minus 50 plus 7, which gives us a negative, I believe it's -18. Now to find our y-intercept, I just have to substitute into the equation 0. So my y-intercept is 0, 7. It's a reflection. And I'm just going to sketch it. I know my vertex is way below, so I'm not going to be able to graph the picture there, but you have some understanding of it. We do know that the domain is all real numbers. We know that the range is y is greater than or equal to the lowest point is -18, and that is a minimum. It's a minimum point. We also know that the axis of symmetry is x equals -5. And we do know the vertex. Unfortunately, the vertex, we're not able to see it in this picture. But I did graph it over here on the left. Here is the vertex, -5, -18. Identify the vertex, the axis of symmetry, the max and minimum point, and the range of the parabola algebraically. We first have to identify the a value, which is 1, identify the b, which is 2, and identify the c, which is 1. Then we're going to use the axis of symmetry formula. So we have x equals -2 over 2 times 1, which is -1. Now the next step is, since we already know the axis of symmetry, we can find the y value of the vertex. So it's y equals -1 squared plus 2 times -1 plus 1, which gives us 1 plus -2 plus 1, which gives us 0. So the vertex is -1, 0. So now we need to know what is the y-intercept. Since the y-intercept, since x equals 0, we have y equals 0 squared plus 2 times 0 plus 1, so that's equal to 1. So the y-intercept is 0, 1, and this is a reflection. So here is my graph. Here is my graph. There's a sketch. The vertex, -1, 0. It's a minimum point. The range, y greater than or equal to 0. The domain, all real numbers. The axis of symmetry, x equals -1. We're going to go from standard form to vertex form, and we're going to use the axis of symmetry formula. So we have a equals 2, b equals 10, c equals 7. You know, those are the coefficients. So we have 10 over 2 times -2, which is 10 over -4. They have a 2 in common, so it's -5 over 2, which is -2.5. And since we know that the axis of symmetry is at -2.5, it's to the left of the y-axis. So we know that it's going to have to be, the vertex is going to have to be 2.5, comma something, -2.5. Now inside the parentheses, it's going to be a plus 2.5 since we're going to the left. But to find the y value, we're going to have to substitute into the equation. So you have y equals 2, parentheses, -2.5 squared, plus 10 times 2.5, -2.5, plus 7. So we went ahead and substituted -2.5 into the equation, and for the y value as the output, it's -5.5. So what I'm going to do is I'm going to substitute. So we have y equals, I know a is 2, parentheses x. It's a minus, so it's going to shift to the left, so it's plus 2.5 squared minus 5.5. And let's go ahead and check. If you look on the equation on the left, or the graphing equation editor on the left, I graph both at the same time and they overlap, so they are the same. These two are the same equations. This is in standard form and this is in vertex form. So we're going to convert the following to vertex form. We need to identify A. A is 1. B is equal to -4. And C is equal to 6. We're going to use the axis symmetry formula. So it's -4 divided by 2 times 1. So that's 4. Negative times negative is positive over 2. So it's 2. So we know that it's going to shift to the right. So it's going to be x minus 2. Now we've got to find the y. So we have y equals 2 squared, which is 4, minus 4 times 2, which is 8. So that's 4 minus 8 is -4, plus 6 is -2, but we'll check again. 2 squared is 4. 4 minus 8 is -8, plus 6 is -2. So the vertex is 2, -2. So the formula y equals, remember that a is 1, so it's x minus 2 squared, so this is going to go to the right. So let's go ahead and graph that, plus 6. This is 4. 4 minus 8 is -4. -4 plus 8 is 2, so that's +2. So I have x minus 2. See, if I had left it -2, it would be low. Oh, and you see my mistake, I put a 2. Remember that a was 1,